Multiple sensors provide a more complete view of the surroundings and can be used to cross-check each other to correct errors. 94. Path planning. Path planning finds a sequence of segments that a vehicle can follow from origin to destination. Two techniques used for path planning are graph-based search and variational-based optimization techniques. Graph-based techniques can make harder decisions such as how to pass another vehicle /obstacle. Variational-based optimization techniques require a high level of planning in setting restrictions on the vehicle's driving corridor to prevent collisions. 95. The large-scale path of the vehicle can be determined by using a Voronoi diagram, an occupancy grid mapping, or with a driving corridors algorithm. The latter allows the vehicle to locate and drive in an open space that is bounded by lanes or barriers. 96. Drive-by-wire. Drive-by-wire is the use of electrical or electromechanical systems for performing vehicle functions traditionally achieved by mechanical linkages. Driver monitoring. Driver monitoring is used to assess the driver's attention and alertness. Techniques in use include eye monitoring, and requiring the driver to maintain torque on the steering wheel. 97. Understand the driver's status and identify dangerous driving behaviors by using the driver monitoring system, DMS. Sounds an alert when the risk of an accident increases and allows the vehicle to take a calming approach to keep the driver safe. 98. Vehicle communication. Vehicles can potentially benefit from communicating with others to share information about traffic, road obstacles, to receive map and software updates, etc. 99. 186. ISO/TC22 specifies in vehicle transport information and control systems. 101. While ISO/TC204 specifies information, communication and control systems in surface transport. 102. International standards have been developed for ADAS functions, connectivity, human interaction, in-vehicle systems, management /engineering dynamic map, and positioning, privacy and security. 103. Software update. Software controls the vehicle, and can provide entertainment and other services. Some vehicles can acquire updates that software over the internet. In March 2021, ANS regulation on software update and software update management systems was published. 104. Safety model. Mobile's mathematical model, responsibility sensitive safety, RSS 105, is undergoing standardization as IEEP 2846, a formal model for safety considerations in automated vehicle decision-making. 106. In 2022, a research group of National Institute of Informatics, NII, Japan, expanded RSS and developed goal-aware RSS to make RSS rules possible to deal with complex scenarios via program logic. 107. Challenges. Autonomous delivery vehicles stuck in one place by attempting to avoid another obstacles. The primary obstacle to ACs is the advanced software and mapping required to make them work safely across the wide variety of conditions that drivers experience. 108. In addition to handling day/night driving in good and bad weather. 109. On roads of arbitrary quality, ACs must cope with other vehicles, road obstacles, poor forward/missing traffic controls, flawed maps, and handle endless edge cases, such as following the instructions of a police officer managing traffic at a crash site. Other obstacles include cost, liability, 110, 111, consumer reluctance, 112, potential ethical dilemmas, 113, 114, security, 115, 116, 117, 118, privacy, 109, and legal / regulatory framework. 119. Further, AVS could automate the work of professional drivers, eliminating many jobs, which could slow acceptance. 120. Concerns. Deceptive marketing. Tesla calls its Level 2 ADAS full self-driving, FSD, beta. 121. U.S. Senators Richard Blumenthal and Edward Markey called on the Federal Trade Commission, FTC, to investigate this marketing in 2021. 122. In December 2021 in Japan, Mercedes-Benz was punished by the Consumer Affairs Agency for misleading product descriptions. 123. Mercedes-Benz was criticized for a misleading U.S. commercial advertising E-Class models. 124. At that time Mercedes-Benz rejected the claims and stopped its self-driving car ad campaign that had been running. 125. 126. In August 2022, the California Department of Motor Vehicles, DMV, accused Tesla of deceptive marketing practices. 127. With the Automated Vehicles Bill, AVB, self-driving car makers could face prison for misleading adverts in the United Kingdom. 128. Security. In the 2020 concerns over AC's vulnerability to cyber attacks and data theft emerged. 129. In 2018 and 2019 former Apple engineers were charged with stealing information related to Apple's self-driving car project. 130, 131, 132. In 2021 the United States Department of Justice, DOJ, accused Chinese security officials of coordinating a hacking campaign to steal information from government entities, including research related to autonomous vehicles. 133, 134. China has prepared the provisions on management of automotive data security, trial, to protect its own data. 135, 136. Cellular vehicle-to-everything technologies are based on 5G wireless networks. 137. As of November 2022, the U.S. Congress was considering the possibility that imported Chinese AC technology could facilitate espionage. 138. Testing of Chinese automated cars in the U.S. has raised concern over which U.S. data are collected by Chinese vehicles to be stored in Chinese country and concern with any link with the Chinese Communist Party. 139. Real-time prediction. While predicting the behavior of ACs that do not use traditional communications such as hand signals, is a major challenge for human drivers. 140. The real-time prediction of the behavior of other vehicles, pedestrians etc., some of which may be stationary when first noted, is even greater challenge for self-driving cars. 10. Raster-based methods being replaced by vector-based methods in order to overcome the former's lossy rendering, limited receptive field, and prohibitively high cost. The remaining problem is high level of uncertainty that emerges in trajectory predictions as the prediction time frame is extended. Also, if data renormalization and re-encoding are used to update future trajectories each time a self-driving car changes its position, its action is often delayed by 8 milliseconds, potentially causing an accident. Several powerful trajectory prediction models have recently adopted transformers with factorized attention as their encoders, but their scalability is still limited by the computational complexity of factorized attention. Most recently proposed QCNet model uses a query-centric instead of agent-centric modeling, taking advantage of both anchor-based and anchor-free solutions. with an anchor-free module generating adaptive encores in a data-driven manner and an anchor-based module refining these anchors based on the scene context. The model injects the relative spatial-temporal positions into the key and value, both transformer elements, when performing attention-based scene context fusion. 141. Handover. For ACs that have not achieved L5, the ADAS has to be able to safely accept control from and return it to the driver. 142. Risk compensation. The second challenge is known as risk compensation, as a system is perceived to be safer. On average, people engage in riskier behavior. People who wear seat belts drive faster. ACs suffer from this problem. For example, Tesla Autopilot users in some cases stop monitoring the vehicle while it is in control. Trust. In order for people to buy self-driving cars and vote for the government to allow them on roads, the technology must be trusted as safe. 143. 144. Automatic elevators were invented in 1900, but did not become common until operator strikes and trust was built with advertising and features such as an emergency stop button. 145. 146. Ethical issues. Rationale for liability. Standards for liability have yet to be adopted to address crashes and other incidents. Does liability rest with the manufacturer or the driver / passenger, and does it vary with, for example, automation level or merely the specific circumstances? 147. Trolley problem. The trolley problem is a thought experiment in ethics. Adapted for ACs. Consider an AC carrying a passenger when suddenly a pedestrian steps in its way and the car has to choose between killing the pedestrian or swerving into air, killing the passenger. 148. Ethical researchers have suggested deontology, formal rules, and utilitarianism, harm reduction, as applicable. 10. 149. 150. Public opinion has been reported to support harm reduction, except that they want the vehicle to prefer them when they are riding in it. However, utilitarian regulations are unpopular. 151. Privacy. Privacy-related issues arise mainly from the fact that ACs are connected to the Internet. Any connected device offers potential to be penetrated. This information includes destinations, routes, cabin recordings, media preferences, behavioral patterns, and others. 152, 153, 154. Road infrastructure. Whether existing road infrastructure can support high levels of automation has not been finalized. The answer may vary across jurisdictions. 155. In March 2023, the Japanese government unveiled a plan to set up a dedicated highway lane for ACs. 156. In April 2023, Junior East announced their challenge to raise their self-driving level of Kasenuma Line Bus Rapid Transit (BRT) in rural area from the current level 2 to level 4 at 60 km /h. 157. Testing. Approaches. The testing of vehicles with varying degrees of automation can be carried out either physically, in a closed environment, 158, or, where permitted, on public roads, typically requiring a license or permit, 159, or adhering to our specific set of operating principles, 160, or in a virtual environment, i.e. using computer simulations. 161, 162. When driven on public roads, automated vehicles require a person to monitor their proper operation and take over when needed. For example, New York has strict requirements for the test driver, such that the vehicle can be corrected at all times by a licensed operator, highlighted by Cardian Cube Company's application and discussions with New York State officials and the NYSDMV. 163. Disengagements in the 2010s. A prototype of Waymo's self-driving car, navigating public streets in Mountain View, California. In 2017 in California, self-driving car manufacturers are required to submit annual reports to share how often their vehicles disengaged from autonomous mode during tests. 164. It has been believed that